Good. Hello, Mr. Aaron, Mr. Ryan, are you right? Okay, so let's given a positive, let's given a non-negative integer like 5. And we want to know the minimum number of steps to reduce to 0. Okay, so for one step, you can either divide it by 2 if it's even, or minus 1, subtract 1 if it's odd. Okay, and if we want to find out the minimum, so what's the strategy here? Let's say 5. How do we get the 5 to 0?
Subtract 5.
No. You can only subtract 1, not divide by 2.
Subtract 1, 1, 1, 1.
Yeah, but there are 5, like 5 steps, right? So what's the minimum number of steps? 5. Then you subtract 1, it becomes 4, and then?
Divided by 2.
Sorry?
Divided by 2.
Divided by 2, then it becomes 2.
Divided by 2.
Or divided by 2 or subtract 1, it doesn't matter, and then like, yeah? And so that's 1, 2, 3, 4. 4 steps. But if you do this 5, 4, 3, 2, 1, is it the same? Yeah? Okay, so in this case, is it the same?
It's different, but for the top one, you just did 1 and 1.
Oh, 1 and, okay, so yeah, 1 and 0. Okay, so now you have the, so that this one, you have 4 steps, yeah? 1, 2, 3, 4. This step, if we just keep subtracting 1, and then that will be 1, 2, 3, 4, 5 steps. So the minimum is this one. Okay, so what's the strategy here? I mean, what's the strategy? Why we choose the divided by 2 or not subtract 1?
Try divide by 2
If it's possible.
Yeah, if it's possible. If it isn't, then subtract 1.
Well done, yeah. Because subtract divided by 2 is always faster than subtract 1, right? Yeah? Okay, so no, okay. So if we can just write it, yeah, simulation. We can just simulate the process. Right? The strategy is greedy, is that we want to subtract, we want to divide it by 2 if it's even, because that will make the number go down quicker than subtracting 1, right? Okay. So let's say define steps, okay? Steps. And then number. So answer, we have answer equals 0. While number is not 0, right? Look here. If n is n1, if this is what? Odd number, right? If this is odd number, then we subtract 1. Otherwise, if it's even number, we divide it by 2. How can we divide it by 2? N divided by 2 divided by equals 2. Or you can shift it one position to the right. Remember the binary. Okay. Okay, look, binary, yeah? 4 binary is 1, 0, 0. Right? Look here. Eric, what's this in binary?
That is 4.
4, yeah, 4, right? Look, 2 to the power of 2. Then if I remove 1, 0, what happens? What's the value?
Huh?
If I remove 1, 0, shift it 1 to 2, yeah, it's exactly, yeah. So binary, if you shift one position to the right, that's equivalent as dividing by 2. Okay, and then now look, if this is odd number, we subtract 1. If it's even number, we divide it by 2. And then both cases, we need to answer plus equal 1, right? Yeah? And then return answer, yeah? Okay? Simple, easy, yeah? Make sense? Yeah. Look, if n1 is odd number, then we subtract 1. Otherwise, we shift it 1 to the right. That is equivalent to n divided by 2 equal, and then answer plus equals 1. Right? Return answer. The time complexity roughly all log n, right? Because we have this divided to keep dividing, right? It's roughly all log n. Okay. So this is one way of doing it. Yeah. Pretty simple and clear. Right? This is a simulation, we call it simulation. We simulate the process and try to do the division as long as we can, as long as it's even number. Okay? Any questions so far for this one?
No.
Ryan, any questions so far? Do you understand this one? Yeah? Okay. So now let's take a look at the binary. For example, like let's say let's say what's this in binary? 1 0 1 0 0. Okay. What's this in binary? 2 to the power 4, this is 4, right? 8 16. 16 plus 4, 20. Right? 2 to the power of, look, that's 0, 2, 4. So here, this is 4, 8, 16. Okay? So this is 20 in decimal. Yeah? Decimal. Okay? So for each 0, yeah, for each 0, we just have one division. Because if it's 0 at the rightmost, it's an even number, right? Yeah? Am I right? It's an even number, so we just need to divide it, right? So that counts 1. If it's 1, what happened? If it's 1, what happened?
This one.
If it's 0, we need to divide it, right? If it's 1, look, if it's 1, we need to subtract it, right? Subtract it, but it becomes a 0 again, right? Yeah? We subtract it, it becomes a 0. Then what happened? We have a 0. We need to divide it by again. So each one, if we have a 0, we need to add 1. If we have 1, we need to add 2. Right? Am I right? Does it make sense? Yeah. Can you tell me why this is 1? If we have a 1, it's 2. I was just explaining to you. If it's a 0, that's easy to understand. If it's a 0, that's an even number.
Yeah.
Then we just divide it by 2, then get rid of it. If it's 1, what happens? Look, if it's this 1, 1, 1, 1. This is 15, right?
Subtract the last one.
Subtract, then it'll be 0. And then?
And then divide by 2.
So you need to take 2 to get rid of 1 digit, right? Yeah? So we can just convert this number n to binary, and then we count. We count how many of them, right? Am I right? Yeah? Okay, so how can we convert to binary? Easy. So we can do this using the bin function, remember? Let's say this b equals bin n, right? Bin function, binary. Okay, bin here is not a bin, it's the binary, stands for binary. Yeah? And this will give me the prefix, a binary prefix is 0b something. And then look, if it's 15, it will give me 0b 1111, okay? And I need to get rid of the prefix too. So I need to what? So because the first 2 characters are meaningless to me, so I have to start from the second character, yeah, to the end. And then now ones, let me count how many of them. So let's b.count string 1, okay? And then zeros will be equals what? The length of b minus 1, right? Right? Because look, this b is only containing ones and 0. If they are ones, yeah, if this number of ones here. So the 0, I can do this simple mathematics, subtract it from the total length, right? So now return what? Ones times 2, right? Plus zeros. Okay, here, there's one more thing here, minus 1. Why there's a minus 1 here? Look, because if it's 0 here, we already reach the target, but we add 1, so we overcounted 1, so we need to subtract 1. Make sense? Yeah? Yeah? Because if the input is 0, what happens? The result you give me is 1, but the truth is it doesn't take any step, it's already 0. Okay, so we have to subtract 1 here. Look, 0 equals length minus 1, right? So look, if we plug in here, alright? Right? If we plug in length b here to here, look, return 1 times 2 plus length b minus 1. So this will become simplified. This return 1 plus what? There are 2 1s minus 1 1, so there's only 1 1 left, plus length b minus 1. Okay? Look, this function converted. We already have these inbuilt functions to convert the integer to binary string. Yeah? And we have to get rid of the first 2 characters because the first 2 characters is always 0b. Okay? We don't need this. We need to get rid of it. Okay? So how can we? Okay, so let's review. We talk about how to convert the number back into the integer. Yeah? Okay, let's review a little bit. I know B. Okay. So now look, 0 1 0 1 0 0. How do we convert this into how do we convert into decimal? So first of all, if it's 0, we start from the right hand side. Yeah? If it's 0,
Delete it.
it's 0. If it's 0, it's 0. But we look, this is 2 to the power of 1, 2, right? Plus 2 to the power of 0, we just skip it. And 1, actually we need to count how many digits on the right. So there will be 1, 2, 3, 4. So 2 to the power of 4, right? So the number is this, yeah. And how do we do it back? Like 15, how do we know? Let's say 14, okay? 14, what's the 14 in, this is the decimal. How do we convert it into binary? Look, divided by 2, 7, which is remainder is 0. Divided by 2, 3, which remainder is 1. Divided by 2, 1, remainder is 1. Divided by 2, 0, remainder is 1. Okay, and it's 0. So now we write this back. So the 14 in binary is 1110. Okay? Yeah, make sense? Yeah? Look, we divided by 2. We had, how do we call this? Quote, you know, how do you call this? What's 14?
Quotient.
14 is quotient, yeah? Divided by 2.
No, the dividend divided by the divided.
Okay, so which one is divided? Dividend.
Dividend. Yeah, that's
Divided by 2. What's this? I divided by
Divisor.
divider. And then what's this?
Quotient.
Quotient. Okay, so quotient. And then I keep dividing by 2. I write the remainder. Here is remainder. Right? 14 divided by 2 remain 0. 7 divided by 2 remain 1. Okay, I write it remain here. And then the opposite way. You write it this. The binary is this equals 14. Got it? Yeah? Let's write another one like 25. Okay, what's 25? Divided by 2. 12. Remainder 1, right? Yeah? Because it's odd number is 1. Divided by 2. 6, 0. Divided by 2. 3, 0. Divided by 2. 1. Yeah? 1. Divided by 2. 0. 1. Okay, so the result is 11001. Okay, let's confirm. 11001. What's this in decimal? That's 1, 2, 4, 8, 16. 16 plus 8 plus 1. 25. Okay, we got 25. You got it? Two ways of, yeah, binary. That's binary. Yeah. Okay? Makes sense? Okay. That will be it today. Thank you. Bye bye.
Bye bye.
Bye bye.